Hi, we're the Fluor Water Desalination Plant Design Team. The overall goal of the project was to come up with a conceptual design for a seawater desalination plant in the city of Doha, and our specific team was the Seawater Transportation and Supply Team, comprised of Jonathan Fisher, Christopher Kirkland, Brian Reed, Jeff Sparks, Harrison Wanick, and Chakotay Kamdu. And I'll go over everything involved in our project and explain that later on. So here you can see a schematic with the solution for our intake and our transportation from the seawater to the plant. So the seawater enters 4 horizontal velocity caps shown at part V, and then are transported from them to the in the GFRP pipeline to our wet well shown in the schematic, where the water enters a pipeline and allows sand to settle out as it travels through the wet well through the vertical band screen shown at B, and then are entered into our vertical turbine pump at P, and then are pumped and transported 8 kilometers inland to the plant, where they are bumped up in pressure by the booster pump shown at D. So here's a star CCM wet well model, showing the model our wet well and a physical model using star CCM to validate our dimensions that we chose for our wet well, and if they would be sufficient enough to allow the sand to settle out before they are pumped up into our pump, causing failure in the system. And in here you can see the intake pipe where the water is introduced into the wet well, and the sand baffle before the pipe, and then the baffles used to represent the vertical band screen, and the vertical turbine pump is shown as well. So here I'm going to explain our physical model. As shown in this video, we built a horizontal flow channel, which we introduced different grain sizes intermittently and allowed them to flow in the system and settle out, where they are then trapped by horizontal flow channels, and then we would drain the system and scoop everything out and weigh it and get a distribution of our sand settling time. As shown in our plot, where you can see it took a considerable longer distance for the smaller grain sizes to settle out than the larger sand grains. This data was able to give us an idea of the distances required for the different size sand particles to settle out in our system, allowing us to determine the dimensions needed in our wet well design. We would like at this time to give a special thanks to our sponsors, Fluor, along with the associate professors Dr. McAdam and Dr. Schuler, as well as everyone at the TAMU Engineering Innovation Center.